Conservative vector field, very simple definition. The integral of f dot delta s from point A to point B, however you parameterize it. Well, I was going to tell you what it's equal to, but I'll do that next. The definition is this is independent of the path from A to B. Now in physics you've been using the fact that a conservative vector field is independent of the path from A to B in calculating potential energy changes. Doesn't matter how you get from here to here, the change in potential energy is the same. Doesn't matter if we go directly along a line, go directly up and over, or follow some silly corkscrew path. It's the same. And here's where we're going to actually see why. Okay? Okay, so this is what it means to be conservative. Well, this is equivalent F is the gradient of V for some scalar function V. Okay? In other words, if this is true, then there has to be some field V that this is the gradient of.
So it's differentiable?
Huh?
So in other words, it's differentiable?
It's what differentiable?
F is.
F? No. I never said it was. It's the gradient of some vector field V, or some scalar function V, okay? Called the potential function. Is in like potential energy. Where we would call it U, okay? Now, does it follow that F itself is differentiable? Well, V would have to be twice differentiable, right? And in almost any application I can think of it would be, but is it necessary? Good question. Think about it, okay? But it's not particularly important right now. This is a definition, and the important thing is to understand that if the integral is independent of the path, then you can find, theoretically, a V function, such that F is the gradient, okay? And very easy to prove that if F is the gradient, then the thing is path independent, okay? Not only that, but the big deal just fundamental theorem. Because in this, F is essentially a derivative of V. Okay, so V is antiderivative of F. So the integral from A to B of F is the change in the value of the antiderivative. Totally analogous to the fundamental theorem that you love so well from first year calculus. Okay? So that's a great big deal. And it just means, in terms of a work integral, because that's how work integral is done, right? That the work done over an interval is the potential energy at B minus the potential energy at A. Okay? sort of. You got a negative sign involved, but still. Okay? Make sense?